Alright, let's see if that mic is working. Hello everybody and welcome back to My Tutor. This is day 8 of the My Tutor squads, so welcome back everybody. I just want to quickly apologise for my appearance today. I have a cold and I had the flu, so I'm not at my best, so if you guys could just be kind to me today and nice words, that'd be fantastic. But yeah, as always, we will start at 5 past, so if you're just jumping into the stream, let me know by just typing a quick message in the chat, and then at 5 past we will get started. I will also mention this at 5 past when we will actually start the lesson, but we are going to use a website today that we haven't used before. This particular website that we're going to use has a bunch of databases which are really useful for machine learning algorithms, because when you're making one, you probably want a database to, run it on. And the good news about this website is the databases are free to use. So there's a bunch of really cool ones on there, and I'll give you guys a link. However, to access this database website, you will need to use either an email or a Google account, or I think even a Facebook account. So make sure that you guys have that handy with your email or your Google account, so you can quickly just sign in. I'll also put the link to the website at 5 past in the chat, so you guys can all use that. And yeah, more announcements on the way. I also apologise if my voice isn't as expressive as it normally is. Yeah, I've been feeling quite unwell today, but I didn't want to leave you guys without a video, so. And yeah, like I said before, we will be starting at 5 past, so if you're just joining us, don't worry, you've got plenty of time to get yourself ready, get yourself a drink, get your computer all set up, and get ready to do some more AI algorithms. Hi there, Michael. Nice to see you again. Hope you're doing well. I really like the fact that I can recognize people's names and profile pictures now. It's really nice. Ah, hello there, Comet. Nice to see you. Nice to see you again. Four viewers. Hello there, Annabelle. Nice to see you again. Oh, yep, and Inga has just put into the chat, we have a form that you guys could fill out. If you could fill it out for us, that would be great. It only takes 5 minutes, and it just helps us improve all these squads. And yeah, Brian has said, Brian, nice to see you again, Brian. And that is 5 past, so we will get started. First of all, as always, can you guys see the presentation on the screen? If you can, please type yes into the chat so I know everything's working. Can no one see it? Is it not showing up on the screen? Can you guys hear me? I'm wondering if the chat might not be working. Okay, I'm going to assume that you guys can see the screen and there's just something going wrong. Okay, I will continue, and if anyone can't see the screen for whatever reason, just let me know. But yeah, we will continue with, there we go. We got a message there saying I can see the screen. Whew, I was scared there for a second that you guys couldn't see it, but that's wonderful. So yeah, welcome back to another episode of My Tutor AI Squads. This is day 8, and today we are going to be covering another type of algorithm called naive Bayes. So just to have a quick recap of some of the machine learning algorithms that we had already looked at. We have looked at things like nearest neighbor. We did that last time. Hopefully a few of you remember the Titanic algorithm where you could predict whether or not certain people would live or not live on the Titanic. But one thing we haven't covered yet is probabilistic, can't say that word very well, probabilistic algorithms. And one of those is naive Bayes. So naive Bayes is a type of algorithm that helps computers make decisions based on probabilities. And the reason it's called naive is because it assumes that all of the features of something are independent of each other, even though that might not be true. So let's say we wanted to create an email spam checker, like on the screen. Our algorithm would first look at a bunch of emails and try to figure out which ones are spam and which ones are not spam. And we'll give the algorithm a bunch of different features to look for. So these features could be like the email contains certain words that are common in spam emails, or the email is from an unknown sender, or the email has a subject line that is written in alternating caps or all caps. So the algorithm will take all of these features and then calculate the probability that the email is spam or not spam. For example, if the email contains a lot of spammy words, or is from an unknown sender, the algorithm might think it's very likely to be spam, so we'll give a high probability for that. Now let's say that we get a new email that we've never seen before. This is kind of like our test data, if you will. The algorithm will look at the same features in the new email and then calculate the probability that it's spam or not. If the probability is high, then the algorithm will classify the email as spam. If the probability is low, it will classify the email of not spam. So that's basically how naive Bayes works. It looks at a bunch of examples and tries to figure out how these different features are related to each other, and then uses that to then make predictions on new examples, on new test data. Does that all make sense before I move on? It's pretty important that that all makes sense. Yes, okay, fabulous. If you guys have any questions on that, feel free to just ask. I'm more than happy to explain things or go back a step and stuff. So now that we've explained what a naive Bayes model is, let's start to actually create one. But before we create one, we will need some data to be able to test it on. So I'm going to give you guys a link in the chat. I will also put the link up on the screen. to this website here. Okay. So this website is called Kaggle. It has basically a bunch of different data sets. I mentioned this in the beginning, but maybe a few of you weren't there. But it has a bunch of different data sets on pretty much anything. It has it on celebrities, world news, chat GPT tweets. So you can basically now make a machine learning algorithm on practically anything. And the one we've got today is a email spam CSV. So what I'd like you guys to do is you'll have to sign in with an email or a Google account. I'm going to quickly hide the screen while I do this. But it's free, it's easy to use, and once you've signed up, you can use all the data sets you want to. So what I recommend you guys do is download this CSV and put it on your computer, and then when you're done that, let me know and we'll get started with programming. Also, you will need to unzip it. It is a zip file. Hopefully you guys have seen that before. If you haven't, it's really easy. You just click on the zipped up folder and then you unzip it and then you can use it as so. So I will give you guys a few minutes to get that all sorted out. What's a zip? Where do I download? So a zip file is basically a file that is compressed and you need to extract it on your computer. I'll show you guys how to do that on my computer as well, because I imagine a few of you haven't done it before. But once you log into the Kaggle website with your email or a Google account, you should be able to click the download button, and then it's really easy from there. And then just to show you how to unzip a file, your computer says it's a harmful file. Trust me, it's not a harmful file. It's completely safe. Is it a virus? It's not a virus. I would not ask you guys to download a virus onto your computer. So when you download it, it will look like this, a little zip file. So what you do at the corner here where it says open, you're going to open it with, you guys will have Windows Explorer. And as you can see here, all there is just an Excel spreadsheet file. It's called emails, so you're going to press extract all. It will ask you to extract it somewhere. You can extract it in your downloads file or your desktop or wherever you'd like to extract it. You just click that extract button and then boom, it's all extracted and you can open it and it's easy to use. Also, I've now realized that light is coming through my window, which is giving me a really great shadow here. So I apologize for that. Okay, Michael has done it. I'll give you guys like a few more seconds. But while you're waiting, have a look at this spreadsheet. Basically, this spreadsheet contains about 5,000-ish emails, and then on the columns here are all the words that came up in these emails and how many of those words. So, for example, A comes up quite a lot, whereas if you go something like Jones or verify, that shows up a little bit less. And then right at the end of the spreadsheet, there is this column here called prediction, and that would be either a 1 or a 0. 0 meaning it's a safe email, and 1 means it's spam. Yeah, I know that. That's why I showed you how to extract it without using WinRAR. So I have WinRAR on my computer, but you can just extract it by clicking that open button at the top. The only difference is that my one will look slightly different, but I've extracted it using Windows tools. So you can just do that by clicking Windows Explorer, this one here. You won't need to click that as an option because it will already be the default option on your computer. You click that and you can extract it as normal. Just extract all, bish bash bosh, all done for you. No WinRAR required. But sorry for the confusion. Alright, I'll give you guys one more minute and then I will move on. You will also need to use the website that we were using last time to do the programming. This was the website that we did all the Titanic stuff on, Google Colab. I will also put a link to that as well in the chat so you guys can just quickly go onto it. There you go. And basically this is the website that we used last time to do all of the Python programming stuff. So I'm going to get that up on my computer now. Should look like this. So when you open up the Collaboratory, it will have this lovely homepage, and then you'll click File, New Notebook, and you can create yourself a new notebook. You can call it whatever you want. I'm going to call it Naive Bayes Emails, but feel free to call it whatever your heart desires. And when you guys are ready, let me know. Are you getting paid to do this? Yeah, I am getting paid to do this. It's my job. Alrighty, we only have about 12 minutes left, so I'm going to get started on the coding. If you guys need me to slow down at any points or explain something again, let me know, but let's get through some coding stuff. So once you've got Google Colab up and you've got your CSV downloaded, we're going to start in the same way that we did last time with importing all of the libraries that we need. For those who don't know, libraries are a thing in Python that you can use to then use other people's code. We are going to be using two different libraries here. We're going to be using pandas for handling the dataset, and sklearn, which is using all of the Naive Bayes machine learning stuff. It has a bunch of machine learning algorithms on there if you guys are interested. But yeah, that's what we'll do now. So you're going to do your imports. So import pandas as PD, and from sklearn, I can spell sklearn, dot naive underscore Bayes, import multi-nominal, I've got to make sure I spell this correctly, nominal NB. I'm also going to make sure you guys can actually see this. You can. Fabulous. Okay, so those are your two imports, your two libraries. And to make sure that's working, you can also press this little play button, and if you get no errors, you've done it correctly. And if you do get errors, you've probably spelled something incorrect. So we'll just wait for this to do its thing. Okay, no errors. That means we've done it correctly. So once you've done that and you've got your libraries installed, You then want to import your data from your computer to this little program here. We're going to do that using Google Colab. So we're going to use this import from google.colab import files, and this allows you to upload any data set that you have on your computer to this notebook. And we're going to save that in a variable called uploaded, and we're going to say uploaded equals files.upload, open brackets, close brackets. Now when I run this little code here, it comes up with this little, what's it called? Browse button here. So I can use that to browse any of my files. So if I go to downloads and I go into my archive emails, I can now start to upload that emails file that I extracted from the computer and put it all in here. As you can see here, it's downloading at the pace of a snail. Since this is going about as quick as I expected it to, should give you guys enough time to catch up on any of these steps that we've taken. If you have any questions or need me to go back at all on anything I've just done, please let me know. That's what I'm here for. I'm now thinking I probably should have uploaded all the data onto this first before doing any of this. Whoops, I didn't think of that. Okay, while this is running, I can show you the next bit of code that you're going to do. So after this, while this is running, you're going to press code to make a new little code bubble, and I'll show you what you'll do once all of your CSV file is downloaded into the notebook. So once you've got it downloaded, you are going to read the file using pandas. And you're going to read that into a variable called email dataset. And you're going to say PD to call the library, read underscore CSV, open brackets, close brackets, speech marks, emails.csv, because that's what it's called. And then that's all downloaded into that email dataset. The next stage is, once it's all downloaded, what you want to do is you want to separate the labels and the data. So you remember at the top of this screen where I have all these columns? Well, we don't really need those in our data. We also don't need the email number, for example. So we're going to get rid of all of those. So I will show you how to do that now. So we're going to write labels equals email dataset Are you okay? Square brackets, prediction. And then we're going to write, and this gets rid of all of our labels for us, and then we're going to write data. We're going to also drop the spam column and the email number column because we don't need those. So we're going to write data equals email underscore dataset dot drop. And then in here, we're going to say we want to get rid of prediction and we want to get rid of email number, making sure that you spell this correctly. So make sure you spell it in the same way that it is in the datasheet. And we're going to tell it which axis it's on, and the axis is 1. Okay. We're at 70-80% of our data. The next step is we want to create a testing set. Now, a testing set is we need to prove whether or not our machine learning model actually does what it's meant to do, i.e., test between whether we're looking at spam or not spam. So what we're going to do for that is we're going to exclude the last 4 rows and we're going to use that as our testing model. So we'll drop the last 4 emails from the dataset, save them in a new variable, and then store all of the others in a separate variable. So we're going to have 2 variables, one for training and one for testing. And we'll show you how to do that now. So testing set is going to be data test equals label data. And we want the last 4 rows. So this is a trick in Python, how to get the last 4 rows. You go -4 colon, and that gets you the last 4 rows. And we'll also want the last labels. So the labels are being the prediction. So labels test equals labels. Cool. So I'm going to take a quick stop here. Does anyone have any questions on what I've done so far? I'm seeing a lot of confusion, I'd say, in the chat. Yeah, how's everyone faring? Okay, I'm just going to assume that everyone's doing magical, and there's no issues. So I'll keep going. So just to prove what I've done here with this whole data testing set here. So if I print out labels test and just run that part here, what should print out... Oh, I spelled prediction wrong. Prediction. There we go. That should make it work now. Yeah, so this is the last 4 emails, and as you can see, the first one is not spam. The second and third are spam, and the last one is not spam. Now we're going to make our training set, but we're going to train our model on, and unsurprisingly, we're going to do the exact same thing as we did before, but we're just going to use everything but the last 4. So for our training set, we're going to have data train is the data, but this time we want everything but the last 4. So we're going to write it like that, and we're going to do labels dot underscore train equals labels -4. And just to prove that I'm not messing with you guys, if I print labels train, it will now hopefully print out all of the other ones. I spelled it, if I can spell it correctly, which I seem to not be able to do today. There we go. So it's not printed out all of them because that's a bit of a waste of time, but there you go. So we've got our 2 sets, our testing set and our training set. What we're going to do now? Well, it's time to train. We are now going to use the function fit to make a machine learning model and then fit all of our data to the machine learning model. So we'll need 2 lines for this. First is model, and we want to specify which model we want to use. So that's multi-nomial NB. and then the alpha, I'll explain what alpha is another time, is 1.9, and then we want to fit our data to it. So fit data, I can see that we're running over, so I'm going to make this really quick. Labels. Train. Hopefully I spelled that all correctly. Yes, we only got a warning, but that's fine. Cool. So then, once you've done it, you can now test your model with the test data. So we will need to predict whether an incoming email is spam or not. So we're going to use those four emails that we separated in data test to predict if they're spam or not and see how accurate is the classifier that we made. So let's make a predictions test. So we're going to make another code and we're going to write predictions. Did I spell that correctly? Predictions test equals model.predict data test. And we're going to print predictions test. And hopefully we should have 100%. Print predictions test. Copy and paste that to make sure I spell that correctly. If I print that out, yeah, it is 100% correct. If I go back up here, we had a non-spam, spam, spam, not spam, and our prediction is the exact same thing. It was able to use the old data, make a model, try it out on the new data, and get the exact same results. It's 100% accurate. Quite rare, but we are doing it on a very, very limited system. So yeah, that is basically how naive Bayes algorithms worked. So, just to wrap up this session, we covered a probabilistic algorithm called naive Bayes. Naive Bayes is a type of algorithm that helps computers make decisions on probabilities, and we use that to make an email spam checker. I hope you guys enjoyed this session. I know that I did. And thank you for showing up every single week. It's nice to see all your faces, well, not faces, but your profiles every single week. And tune in for the next time when we're going to do more machine learning algorithms. But thank you, and see you guys next week.